so we used the process here, starting with Go, and that was to build the theremin. And next we moved to, once we figured out our goal, was the design process, which we figured out using a schematic how we were going to actually construct the theremin. And then we constructed the theremin using components like on a red board. And so we used a variation of these components, like there's an LED, which is a light emitting diode, and here is a transistor, which acts like a switch to divert current to different paths, and resistor to resist current, and various capacitors like polystyrene and electrolytic, and polarized and non-polarized capacitors. And then we took this and
take the idea of it and put it in the theremin. So first, let's talk about the capacitors, because they will play an important part in this theremin device. So let's not talk about the polarized things first. The capacitor works by charging two chips inside it, one with a positive charge and one with a negative charge. And when releasing electricity, it uses the attraction between the positive and negative. When we activate the theremin device, the antenna gets charged with negative force. And when your hand gets close, it will form a capacitor between your hand and the antenna. And this capacitor is a component of another circuit called the oscillator. An oscillator generates a signal of a fixed frequency, depending on the components, the resistance and the capacitance of its components. So there are two oscillators in this device. One generates a fixed frequency, which is around 1 million hertz, and the other one, because it's hooked up with the capacitor between of the antenna and a variable resistor, so its output can vary. And then comes the mixer, which mixes the two signals together, and it generates two new signals, which is the frequency of their sum and the difference. And it also has a filter that filters out the sum, so that the difference will be amplified and put onto speaker, and that's what you hear.
So we took the variable oscillator, and then it displays through current, goes to a speaker and displays that sum in the form of noise. So we tested the frequencies that we were getting with this oscilloscope here. It's a very old one, and like I said earlier, it did not work very well. So once we got the new one, we actually got an accurate reading. We should have been getting around 1 megahertz when we were getting 100 or 100 kilohertz. So that's what we were getting for those frequencies until it actually worked.
So because of the inaccurate reading, we rebuilt this device 3 times, and just to find out that this old oscilloscope is broken.
So,
Alright.
So we patched the breadboard together, so we did not have to use a soldering iron. So we finally got it working after 3 tries, and now both oscillators are working in the fixed and variable, so it does generate the right amount of frequency.
Yeah. You want to try it?
You want to show?
Yeah, let's see if it works. It's working like a few minutes ago. Yeah, did it all?
Yes. It should.
Good.
Wait, did you? Yeah.
Yeah, it's just the power connections.
Yeah.
Not very working very well.
Not very stable.
So that's a demonstration of the Theremin device.
Can you play Star Trek?
That's gonna be hard.
Yeah, that's a whole other thing.
You can try.
It's gonna be retuned though, right? It's a little,
Yeah.
Can you?
You want me to tune it?
Can you try? Can you try?
Yeah, the tune is very sensitive, so I'm
Very sensitive, yeah.
Very sensitive.
Doubtful.
But meanwhile, let's give them a round of applause. Great job, guys. And the presentation was very clear. I was able to understand everything that they were saying. So that's great. That shows that you have understood all those concepts that you practiced. So both the teams here, great job, guys. Thank you. And you have an opportunity to say hi to Noah, and he is an embedded systems engineer and IEEE vice chairman, and he is the person that conceived and gave us the idea. So it's a great opportunity.
You want to try to tune it or no?
You can give it a whirl. Enjoy, sir.
Huh. So we can get it tuned. Yeah, this thing is really tough to tune. It's kind of